All right, good morning. Let's take a look at our objectives and learning targets for section 1.6 to 1.8. Our first objective here, as it says, I'll be able to solve systems of equations graphically and algebraically. So on your test, you're definitely going to have problems where you're going to be asked to do this one way or the other. So if they ask you to do it graphing, or do it by graphing, we're just looking for, do the points intersect or don't they? Okay, and if they don't intersect, then we have parallel lines, no solution. If they're the same line, you have infinitely many solutions. Otherwise, we're just looking at one point of intersection. So it's one of those three options. So the ideal part when graphing these is hoping that y is all by itself, like the first equation here. So right away, I can look at this and say, all right, my slope is 3, my y-intercept, okay, is -2. And remember, this is a formula, y equals mx plus b. You gotta know, love, make your best friend. Number in front of the x is the slope. The b is your y-intercept. Those two values help a ton with graphing. So here I'm starting at -2. So I'm going up 3 to the right 1, up 3 to the right 1, up 3 to the right 1. Now I can go down 3 into the back 1, so I can get all the points. I have a nice solid line because we do have the equals. These are all just equal equations. And I got my first line. Now to do the second equation, you do have to get y by itself. So you have to do a little bit of algebra. So the first thing I actually have to do is get the x's to the other side. So I got a -3x. So what I do, I'm left with 3x's cross out, so I'm left with 2y equals -3x plus 14. Divide both sides by 2, so y equals -3/2 x plus 7. So now, when I look at this one, my slope is -3/2. My y-intercept is 7. So when I go to graph it, 1, 2, 3, 4, 5, 6, 7. On my y-axis, down 3 to the right through 2. Bam, right there, I get my point of intersection. So I got a nice point. First, I want to finish my line. So now, we want to find where the coordinates of that point is. So it's at 2 for x and 4 for y. So you can write your solution as a point, 2, 4, or you can say that x equals 2, y equals 4. Either is an acceptable answer. All right, that takes care of the first one. Second one is just doing the same thing, but we just got to, again, just like we did with the second equation, both of these, we're going to need to get y by itself and y by itself right there. So on the first one, there's just one step. So we just have to divide everything by -3. Biggest thing here is watch your signs. So you get y equals, so -4/3 x minus 5. So now my slope is -4/3. My y-intercept, -5. So to start that one, here I'm starting at -5. Sorry, my equals, sometimes my marker's not working beautifully here. So I start at -5, 1, 2, 3, 4, 5. Now it says to go down 4 over 3. I can try to estimate where that is, but it might be better if I actually go up 4 to the left 3, up 4 to the left 3 to get my points. So we do make these equations and graphs nice enough that they should intersect somewhere on that coordinate system. Okay. All right, let's do the second one. So now with the second one, we got a couple steps to do here. I'm going to get y by itself. So I'm going to subtract 2x, subtract 2x, careful. Don't forget there's a negative in front of that y. Negative y equals negative 2x minus 5. So to get rid of the negative, I'm basically dividing everything by negative 1. So y equals 2x plus 5. So my y-intercept, I'm sorry, I almost skipped the slope. The slope is 2. My y-intercept is 5. So I'm starting at 5, 1, 2, 3, 4, 5, up 2 to the right 1. So I'm going to have to actually go back to down to back 1, down to back 1 to get all the points. What's nice is as I'm doing that, you saw right here, they intersected nicely. So again, just like I did on the previous one, I can write my solution as an ordered pair. So 1, 2, 3, negative 3, negative 1. Or I could write it as x equals negative 3, y equals negative 1. Now, one of the things I haven't done, but just want to let you know, you can check to make sure your answers are right on both of these problems and all of these problems. So just to show you how you check, I'm not going to show on every single one, but like on this first one back here, if I wanted to check, I just simply plug it in here and say, all right, 3 times 2 is 6. 6 minus 2, sure enough, is 4. 3 times 2 is 6. 2 times 4 is 8. 6 plus 8 is 14. It works. Okay? The key thing with these problems is they have to work for both equations. Don't just check one, check them both. All right, so that's graphically. The second types of problems here, it says solve each equation by using substitution or elimination. Now, this is basically solving it algebraically. You get to choose. Okay? Whichever one you like better, do it that way. But I tell you right now, I like to use substitution when x or y is by itself. Okay? I tend to use elimination when x and y are on the same side. Meaning the same side of the equal sign. So when I look at this first one, number 3 in this review here, notice how they both say y equals. So it's just a matter of replacing one of the equation with what y equals. So what I can do here is say, all right, here's what y equals. So I'm going to take this 2x minus 10 and put it in a place of that y right there. So now I just have 2x minus 10 equals negative 4x plus 8. Now I have a simple algebraic equation, and I just need to solve for x. So I'm going to do both steps. I'm going to get x's to the left side, so I'm going to add 4x. And then, since I have x on this side, I'm going to take the number and move it to the other side. So I'm going to add 10 to the other side. So I have 6x now, 10's cross out, 4x's cross out, equals 18. Divide by 6, and x equals 3. Now, we're not done, because we only have x right now. I need to get y. So the beautiful thing is, you can just take your answer, plug it in, and figure out what y is. So we get y equals 2 times 3 minus 10. So y equals 6 minus 10, or y equals negative 4. So I got my x and I have my y. If you're one who likes to write it as an ordered pair, you could write that as 3, negative 4. And that is totally fine. So just a quick check. So again, does 2 times 6, or sorry, 2 times 3, which is 6, minus 10 equals negative 4? Yes, it does. Because negative 4 times 3, which is negative 12, plus 8, that also equals negative 4. I know my answer is correct. All right, so, the second one here, number 4, is an interesting case because notice how x or y is not by itself and x and y are not on the same side. So I have to decide which method I want to use on this one. One of the other things I look for is, does one of the equations just have an x in it or a y in it? And the first equation just has a y in it. So if I move my 2x over to the other side, which I'm going to do here, then I got y by itself. So to do that, I have to subtract 2x. Subtract 2x. So y equals negative 2x plus 9. So now, I'm going to take this piece and put it in the place of y right there. So here I have negative 3, and I need to put this in parentheses. Negative 2x plus 9 equals 24 plus 6x. So now, what I need to do is distribute and simplify. So I have 6x minus 27 equals 24 plus 6x. Just like I did before, I want to start to get variables to the other side. So if I subtract 6x, one of the things you'll notice here is, wow, the x is crossed out, and I'm left with this statement, negative 27 equals 24. When that happens, as we've discovered, this is a false statement. So what that means is we have no solution because the lines happen to be parallel lines. So if we were to actually graph these, they'd be two parallel lines that never intersect each other. So don't be surprised on your test that you might get something like that to happen. Now, there's another case that we'll talk about that will pop up a little bit later, and that's that infinitely many solutions. All right, let's look at number 5 here. Number 5 is really nice because x is all by itself. So again, I'm using this substitution method. So I'm going to plug x in there. So as I do, I get negative 3 parentheses 10 minus 3y plus the 2y equals 3. So negative 30 plus 9y. Okay, make sure you're distributing the negative 3 plus 2y equals 3. So as I start to combine like terms, I got negative 30 plus 11y equals 3. I have to add 30. So I have 11y equals 33. Divide by 11. So y equals 3. I'm going to plug that back in to the first equation to get my x. I'm just switching colors here. So then x is equal to 10 minus 3 times 3. So x equals 10 minus 9. So x equals 1. So again, quick check. Okay, 10 minus 3 times 3 is 3 times 3 is 9. 10 minus 9 is 1, so that works. Negative 3 times 1 is negative 3. 2 times 3 is 6. Negative 3 plus 6 is 3. So we're doing great. So again, feel free if you wanted to. I might forget to do this, but you can also write this as the ordered pair 1, 3. Again, x, y is how we put those in order. All right, pardon me as I move this up just a little bit, makes it a little bit easier for me to write. All right, so now, the next example here is a typical one where I like to use the elimination method. And this one's actually pretty nice because look at your y values. They're already opposites of each other. Sometimes I think of the elimination method as multiplication addition. So I don't have to do any multiplication. One of the things I can actually do, simply add these two equations together. So 4x and 4x make 8x. My y's cancel out, and I'm left with 29 and 35 make 64. Divide both sides by 8, and look at that, I have x equals 8. So quickly, I got one of the variables. Now, the only downside of the elimination is getting the other value does take actually a tiny bit more work. But it's the same process. Plug it in and simplify. So 4 times 8 minus 3y equals 29. So 32 minus 3y equals 29. Subtract 32. So negative 3y equals negative 3. Divide by negative 3. Y equals 1. So a quick check. 4 times 8 is 32. 3 times 1 is 3. 32 minus 3 is 29. 4 times 8 is 32. 3 times 1 is 3. 32 plus 3 is 35. So I know my answer is right. Again, as an ordered pair, you would write it as 8, 1. All right, let's take a look at the second one. Ooh, so on the second one here, all of a sudden, I look at my x's, they're not the same. The y's, they're not the same, or really, technically, I'm looking for opposites. However, 5 does go into 15 nicely. It goes in there 3 times. So I'm going to take this whole equation and multiply it by 3. The reason for that is when I do that for my x's here, I'll get a positive 15x. So then when I add those two together, they'll cancel. But I'm going to need to make sure I do that with the other ones. So negative 3y times 3 is negative 9y. 3 times 26 is 78. However, look at what happens now when I add these equations together. These cancel out, so you're basically left with 0. Here you're left with 0. They cancel out. Negative 78 minus 78, or negative 78 plus 78 is 0. Well, 0 does equal 0. So what this actually means is they are the same line. And if they are the same line, we have, remember how we abbreviate this, infinitely many solutions. Because every single point on that line is a solution. Since the line goes on forever, that's why we have infinitely many of them. All right, let's try the last one here, and probably the most difficult of these 6 problems here. So for this one, as I look at it, notice how 2 doesn't go into 3 nicely, 3 doesn't go into 4 nicely. So I have to make a decision. I have to decide, do I want to cancel x's? Do I want to cancel y's? There is no one right way, but you just got to pick one and go for it. So for myself, I'm going to decide to cancel the x's. So I'm thinking 2 and 3 both go into 6. So to make 2 a 6, I have to multiply that whole equation by 3. For the bottom equation, I have to multiply it by 2. But now here's the thing you got to be careful about. They're both now positive 6. And when you add 2 positives, they don't cancel. So you got to choose one of these to be negative. I'm just going to choose the bottom one to be negative. However, you could have chose the top one also. So now I got to distribute. So 6x, so 3 times 2x is 6x, 3 times 3y is 9y, equals 12. Distribute the negative 2, negative 6x. Watch the signs, plus 8y equals negative 46. Combine like terms, so x's cross out, 17y equals negative 34. Divide by 17, and y equals negative 2. So I got my y. Now I just need to get x. So again, we'll plug that value in to the equation. Come here and pick one of them. So if I pick the first one here, I have 2x plus 3 times negative 2 equals 4. So 2x minus 6 equals 4. So again, just doing my algebra, add 6. So 2x now equals 10. Divide by 2. Divide by 2. X equals 5. Again, I can do a quick check, okay, just to make sure that it does work. Okay, so 2 times 5 is 10. 3 times negative 2 is negative 6. 10 and negative 6 is 4. 3 times 5 is 15. Negative 4 times negative 2 makes positive 8. 15 and 8 make 23. So I highly encourage you to check and make sure your answers are right. To me, okay, this is a test where you should hopefully know whether or not your answers are correct. All right, let's move on here and go to our second learning target. Okay, so our second learning target here is you'll be able to solve systems of inequalities by graphing and find the coordinates of the vertices of the solution set. Okay, so on the first couple problems, or at least on the first problem here, it just asks you to graph it. Didn't leave a spot to help you find the vertices, but we may do that anyway, just because the blank is missing. All right, so ideally, graphing inequalities, if you remember, the things that we want to make sure we do is get y by itself, and remember when we use dotted versus solid line. Okay, so I'm going to kind of put it over here for a second. So again, if it's a greater than or less than, we use I'm going to use, instead of the word dotted, I'm going to use dashed. If it's greater than or equal to, less than or equal to, you use a solid. Okay. And then we need to remember greater than or equal to is above. Okay. Less than or equal to is below. So these are things you need to know and love and make your best friend. It makes doing these problems so much easier. All right, so for the first one, okay, here my slope is 2. My y-intercept is negative 5. So start at negative 5. 1, 2, 3, 4, 5. Up, and then my slope is 2, so up 2 to the right 1, up 2 to the right 1, and so forth. Now I could go down 2 to the left 1 also. Now, I look at the inequality sign here and I say, all right, this is solid, and I'm shading above. Again, I'm getting these right from here. Solid because it's greater than or equal to, shading above, greater than or equal to. Make a nice solid line. Now, when I shade, I just like to point the arrows and do the final shading at the end. Because sometimes it's hard if you shade and then you shade because you're looking for what they have in common. All right, so the next one, I got to get y by itself. So I have to subtract x. So I have 2y is less than negative x plus 10. Divide everything by 2. So y is less than negative 1/2 x plus 5. So for this one, I'm starting at a positive 5. 1, 2, 3, 4, 5. So then it was a negative 1/2. Sorry, my negative got mixed up with my fraction there, so you can't see, but here we go anyway. Negative. So negative 1/2 is down 1 to the right 2. Down 1 to the right 2. Ooh, we got the point of intersection, which is basically your vertice, or I could go up 1 to the left 2. So now, when I look at this inequality sign, I notice that it's just less than. So that means dash, and it means below. I'm going to dash the line. So usually what I do is I connect every other point that I made. We shade below, so we'd be going in this direction. So I'm looking for where are the arrows pointing. Okay? So we like to call this the feasible region. It helps to know where that is in 1.8. It did ask for your vertices. This one only has 1. Usually we like vertices when we get a closed area. I am going to note this. 1, 2, 3, 4. So 4, and then up 1, 2, 3. It's the only spot really where we have a vertex. Okay. All right, so that takes care of the first one. All right, so we'll keep on going here. The second one's going to get very colorful here because we have 3 inequality statements. All right, so here's what we got to remember for some of these problems is when you just have x or y. Remember that x is a vertical line. So, and I go to x on the x-axis at 3, and I draw my vertical line. So it has the equals, so it's solid. Now, this is basically the only case where the above or below really doesn't work because the above and below rule only works when it's a y is greater than or less than type problem. This is x, okay? But if we think about it, x is bigger, okay? So if this is 3, what numbers are bigger than 3? 4, 5, 6, 7, 8, 9, 10 for x. So we're going in this direction right now. All right, the second one, when we just have y equals a number, okay, or in our case, greater than or equal to, remember that that's a horizontal line. And a lot of things you need to know and remember. Some of these things we actually learned back in Algebra 1, my apologies. So this one again is, just like the other one, solid. In fact, all 3 of these lines are solid. So I'm going to go to my y-intercept at 2, draw my horizontal line. All right, so now our last line here, we got to get y by itself. So we got a little bit of work to do on this one. So the first thing I need to do is subtract x. So I have 3y is less than or equal to 12 minus x. I'm now going to divide by 3. I apologize that I put x last, so I'm going to flip it. So y is less than or equal to, I'm going to put this piece first, so negative 1/3 x. 12 divided by 3 is 4. So start at 4. 1, 2, 3, 4. My slope is negative 1/3. So down 1 to the right, 3, down 1 to the right, 3, down 1 to the right, 3. So again, I know it's a solid line. And my shading is less than. So this is the tricky part here. And I apologize because I forgot about the shading on the green one. It said greater than, so it's above on the green line. Got a little excited and ahead of myself. So, because I know it's above here, green, to the right here, purple. I know my area is right in here, but with the pink line here, it says below, so my feasible region, I'm not going to be able to write the letter F in there because it's so small. It's this tiny little triangle right here. So now I need to figure out where the coordinates are. So my first point right here, 3, 2. So one's at 3, 2. The second point is still 3 up to one more, 3, 3. And then my last coordinate, I go all the way up to 6, 2. All right. We're cruising right along here. All right, now let's take a look at these last two. These last two will take a little bit more work, but will still be pretty, hopefully not too difficult to do. So, again, I know that this is a horizontal line. X is greater than or equal to 1. So, here is where x is equal to 1. I know that it is, I apologize, I might have said horizontal. We're talking about a vertical line. X equals is always vertical. We want to go to the right. So now, this next statement right here talks about y being greater than or equal to -2, but less than or equal to 3. So this is what we call like an in-between statement. Y has to be in between these two numbers. So again, these are horizontal lines. So I start, one's at -2. So here I have a horizontal line at -2. And another horizontal line at 1, 2, 3. It's an in-betweener, so it's going to be in between the lines. So right now our shaded region is this area right here. It's kind of like this rectangle that just keeps on going in this direction. However, we have this last line to graph. And that's what's nice about this problem is that y is already by itself. So here it says start at -4. So I'm going to do that. So here's 0, 1, 2, 3, 4. And then my slope is simply just 1. Up 1 to the right 1. Up 1 to the right 1. Up 1 to the right 1. So I keep on doing that process. Pen's not wanting to register that nicely right now. So now, again, all of mine had the equal, so I have a nice solid line. So now what has happened, it's taken this rectangle area and it's cut a line right through it. I want to shade above it. It's a greater than. So all of a sudden, that's the area right here, or that's my feasible region. Put a big F for feasible there. I'm going to shade in that area. So now I need to figure out my vertices. I actually have 4 of them here. 1 here, 2 here, and then 3 right there, and then there's 1 right there. Notice how that part here got cut off. So there's actually 2 points right there. So now I'm just going to go around and find all of them. So this first one here is at 1, 1 is at 3, and 1 is at -2. So I have 1, the point 1, 3, and the point 1, -2. So I got these first 2. So I keep on going. So if I go out to 2, I'm down to -2. So 2, -2. And then my last point way out here, 1, 2, 3, 4, 5, 6, 7, 3. Cool. All right, the last one. It's pretty challenging here because we have 1, 2, 3, 4 different constraints. But when I look at these last two, x is greater than or equal to 0, y is greater than or equal to 0. This tells you that you are basically sitting in quadrant 1, okay? Basically, x has to be a positive number, and so does y. It has to be positive or 0. So basically, what's happening here is I'm going to graph them both in red, if you don't mind, is I have the x and y axis, and I want all the values that are greater than it, so it tells me that I'm sitting here in this first quadrant. So then all I need to do is graph these other two lines. So for this first one, I have to subtract 2x, subtract 2x. So I have 3y is less than or equal to -2x plus 12. Divide by 3, and divide by 3 for all of those. So y is less than or equal to -2/3 x plus 4. So start at 4, 1, 2, 3, 4. My slope is -2/3. So down 2 to the right 3, down 2 to the right 3. Or up 2 to the left 3. Nice thing is for this one, it's a less than or equals to. So we've been really doing a lot of solid lines lately. So I have it. It's a less than, so I'm shading below. So right now my solution set is this triangle right here that I'm kind of having my pen go around. But I still have one more to do. Let's see. We haven't used brown. So with this one, same thing. This one's a little bit nicer because all I have to do is subtract 2x. And so I'm left with y is less than or equal to 8 minus 2x. Don't have to get any, y's already by itself. So now I start at 8. 1, 2, 3, 4, 5, 6, 7, 8. Now I'm going to go down 2 to the right 1. Down 2 to the right 1. Down 2 to the right. Bam, look at that. Nice intersection point. I could keep going. I might just go just one or two. The key is I'm looking at where it's intersecting in the triangle because that's all that matters for my feasible region. It was a less than symbol. I'm shading below. So here's my feasible region right here. Everything in this quadrilateral. So now I need to find those vertices. So to help me find those vertices, well, one is pretty easy right here because it's actually at the origin. So I have one at 0, 0. One's on the x-axis here, so I just have to find it. 1, 2, 3, 4, 0. Another one is up here at 1, 2, 3, 4, so 0, 4. And then our last one, this point is at 3, 2. All right, excellent. I'm actually going to stop this video and record 1.8's learning target on a separate video.